These are my silver refining filters. Whenever I get done filtering out a batch of silver, I just throw them up here on this little plastic bag. I'm going to put it in this pan here. And here's a few gold refining filters. Might as well throw them in too. This is footage that I shot back in April of 2018. I had just cut down a tree and I was burning the pieces of wood from that, and it made a nice hot fire. And so I seen an opportunity to go ahead and incinerate these filters while I had that nice hot fire going. And so I took the opportunity to use that hot fire to burn all my filter papers. I've had this footage saved on my hard drive for what, 3 years now, almost over 3 years actually. And I did get the incineration completed. You'll see later on I'll throw some more of paper material that I had saved from some palladium refinings and some old filter papers that I had saved up in my paper storage, and just decided to go ahead and use this footage to complete the video. I did save the burnt filters in a separate beaker. They've been sitting in a 2-liter beaker for 3 years now, holding that beaker hostage. And so in this video I hope to complete the refining of these filters and liberate that beaker, so I'll be able to use it for some future videos. Here, like you see, I'm adding some paper from bags that I stored and saved from previous refining operations. And just want to let you know this is old footage, and today we're going to get it up to date and refine the ash from this incineration. Okay, my filters have been on here now for about 2 hours, and there's really nothing combustible left in here. Everything is a fine ash. I'm gonna go ahead and pull it off the fire and let it cool down now. The ashes have cooled off now. I'm going to go ahead and transfer it to a beaker. Here we are. I've finally taken the time to get our incinerated material. What we're going to do is pour it through this strainer here and try to get it into a finely divided state. I'm just going to push this through this fine sieve here, this fine mesh wire screen. I've got most of the material pushed through this screen. This is a nice piece of gear here. I bought this at a yard sale for about 50 cents. It's got a real thick fine mesh screen on it. And here's a look at the material that we've got left in there. Pretty much going to be junk, but I'll save this and take a look at it. Finally get my 2-liter beaker back that's been held hostage for 3 years. Here's a look at the material that's left over. Take a look at this, save it probably, and maybe crush it up a little better in mortar and pestle. But at least get my 2-liter beaker back. Before I go on, I want to give a shout out to Paul Oshman. He is a subscriber, and he sent this very nice piece of gear here. It's a hot plate stir plate with stirring and heat. It's got a nice ceramic top up here. And just like to say thank you very much to Paul Oshman, one of my subscribers. And he donated this to the Sweet Tips Foundation. Thank you, Paul. When this thing came in, I just couldn't get over how nice it was. Thanks again to Paul. We're going to use this today for this recovery. I got a stir bar here. I'm going to drop that in. We're going to add some distilled water here. I've got the stir bar on. Now we're going to add a little bit of concentrated nitric acid, 68 to 70% concentration. I'm just going to add a little bit here because I don't quite know how this is going to react. This thing's pretty nice. It actually gives a temperature on the dial here. It goes up to 644 degrees Fahrenheit, 340 Celsius. So I'm going to turn that about halfway up. And we're going to let this go ahead and just continue to react on our stir plate. I'm going to add in a little bit more nitric acid here. Not much. Just a few milliliters. And we'll let this go ahead and heat up and react. The reaction's been going since 1:15. That's about 20 minutes. And I'm going to add a little bit more nitric acid here. Just a little bit more. About 20 milliliters maybe. We got to add this in slow because our solution is hot now. Add a little bit, just a touch, and see what's gonna happen here. I'm gonna add the rest of this nitric now. It didn't take off too badly. And we'll just let this stir and heat up now. We've got our material in a finely divided state here. There's possibility there may be some silver in here, and there may be some platinum group metals and a little bit of gold. We're going to treat it with boiling nitric acid first, and that will remove the silver and get out any palladium if present. Palladium is the only one of the 6 sister metals in the platinum group that is soluble in just nitric acid. We've been on for about an hour and a half now. I got the temperature up over 200 Fahrenheit, 98.6 Celsius, almost boiling. What I'm going to do, I'm going to crank the heat just a little bit here. And we're going to add another splash
of nitric. It's about 20 milliliters. And if we don't get a big reaction out of this, I'm going to go ahead and conclude that we're fairly close to being done with this reaction. Again, what we're trying to do is pull any silver, palladium, and any soluble material that's soluble in nitric out of our solids with these nitric boils. This has been on now for about 15 minutes. You can see we've got it up to 300 Fahrenheit, 150 Celsius. What I'm going to do is pull this down off of the heat now. Turn the heat off. Turn the stir bar off. Let's pull it down off the heat. We're going to let this cool down. I'm going to add some distilled water. Get this to cool down. Do this careful. This is up over 300 degrees. Just dilute this with a little bit of distilled water. I'm going to stick a piece of filter paper down in here. Get a little bit of the solution on it. And now we're going to do a stannous test to see if we've got any precious metals in solution. I'm getting just a very slight orange-brown stain there, which means we've got a little bit of platinum group metals in solution. Looks like it might be turning a little bit green, so that'll tell us we've got some maybe some palladium in solution. I've got a specially prepared filter paper here that rides up the side of the funnel, and so what this will do for me is this will capture all of the solids. None of the solids will get past the filter and come in contact with the funnel. I'm going to filter the liquid out of our solids now and capture the solids in this filter paper. Here we go. I've got most of the liquid poured in here now. Filtering is already slowed down to just a slight drip there. So before I add the solids, I'm going to pull all this liquid through that filter. Don't want to load it up with a whole bunch of these solids. Still a little bit of liquid in that filter. But what we're going to do is try to wash these solids down into the filter now. It's pretty much like mud. And this is really going to load the filter up and slow this filtering process way down. My stir bars in there. So we're going to try to get that held with a magnet. We've got the solution separated from the solids now. Here's our solids. And I'm just going to put this over here out of the way for right now. I'm going to transfer our solution out of this filter flask now. This is probably going to have some palladium in it. Just going to pour it right into this big beaker. I'm going to draw some of this solution up into a small beaker here, and we're going to test this solution now for the presence of silver. Got hydrochloric acid here. If there's silver in this solution, we'll see a cloud of silver chloride form. And there you can see it. There's a lot of silver in there. A lot of silver. We're going to do another test on this solution now. Reach down here with a little piece of filter paper, get some of the solution on it, hit it with stannous chloride, and you can see a brown, light brown stain is developing. It may be a little bit of an orange tint to it as well, but we've got a little bit of platinum group metals in here. I don't think it's going to be enough to go after and do a complete refining on. Got a 600 milliliter beaker here. I'm going to add some distilled water, turn on the stir bar, I'm going to add a couple of grams of dimethylgloxime to the water here. I'm going to add some heat. Dimethylgloxime is not very soluble in water, but we should be able to get enough of it to go into solution to get the palladium, the little bit of palladium that's in this solution, out of here.
Here I'm adding the dimethylgloxime, or DMG, to the silver and palladium solution there, and this will combine with the palladium that's in that solution and form a precipitate, and we'll be able to get that precipitate out and save it and recover that palladium in a later video.
Give this thing a stir. What we're going to do now is get our solids into this beaker here and start hitting this with a little bit of Aqua regia and see if we can extract some of the metals out of those solids. I'm adding hydrochloric acid. Fill it up to about the 400 milliliter level. I'm going to drop in a stir bar. I'm going to measure out about 50 milliliters of nitric acid here. 50 milliliters. Here we go. We're going to put about 20 milliliters in our solution here, or in our solids. Going to turn the stir bar on, and we're going to add a little bit of heat and let this react.
Here I'm adding small doses of nitric acid so I can get the entire 50 milliliter charge into the reaction. Don't want to put it in there too quickly or we might get a boil over.
The solids have been on the stir plate now for about an hour. I'm adding another dose here of concentrated nitric acid. I think we're almost done with this reaction over here. I just wanted to add a little bit more nitric just to see. Make sure we don't get a whole bunch more fume production in there. I'm going to let this continue to heat and stir. While I'm waiting for that, what I'll do is I'm going to filter out the solids that we precipitated from this solution here. Now we're going to filter the solids out of this silver solution. This will be palladium down here. This is our DMG precipitate, and what I'm going to do is try to rinse as much of the silver off as I can. Just rinsing it here with distilled water. Here's our palladium in this filter right here. And what I'll do, set this over off to the back here. I've got a filter storage container here that has other filters that contain platinum group metals and some other things. So I'm just going to put it right in here. This is a little storage container I use to save my palladium when I filter it out like that. I've got some other filters here that's got palladium in it, and what we'll do is we'll hang on to this. This stuff is very dangerous if it gets airborne, so I keep it in a covered container. I'll hang on to this, and we'll do a refining on these filters and get a nice little bead of palladium. This has been on for about an hour and 15 minutes, maybe a little longer. I'll pull it down off the heat and make some room here. Just gonna set this over here off to the side, and we'll let this cool down. I'm gonna allow this solution to settle and cool off. But in the meantime, I'm gonna reach in here, get a little on a filter paper, test it with some stannous, and as you can see, we got a dark stain indicating that we have precious metals in solution. While we're waiting for this solution to cool down, I've got a piece of copper here. Put it in this beaker, and we're going to add this solution that we just filtered into this beaker with the copper, and we're going to cement this copper out of this green solution here. Here we go.
In accordance with the reactivity series of metals, copper, being higher up in the list, will cement out the silver out of that solution, as well as any remaining palladium that's still in the solution with the silver.
I'm going to stir this up. We're going to set this back out of the way now and let this continue to react. Now what I want to do is get set up to do a filtering here. I've got a filter flask And I'm going to set it up down low down here. Going to add a Wattman number 42 filter paper. I've got a tube full of water here. And now what we'll do is I'm going to siphon off the settled liquid up here into the filter. And we're going to filter this solution out now. Alright, we got the solution filtered, or down into the filter. Most of it.
Here I'm rinsing all of the solids down into the funnel, and you can see there that that material is a gray color, so I think I've extracted all the precious metals.
Every refining is different. There's no standard procedure that can be applied. As we go and encounter different metals in our solids, we have to adjust our process for that. Here you can see there's some precipitate down here. It's probably silver chloride. So what I'm going to do is I've got a clean filter flask here. We're going to get this set up and refilter this solution a second time. I'm just going to scoop them out of this funnel. We'll set these aside and maybe hang on to them. They may contain some precious metals that I'm not used to recovering just yet, such as rhodium. So I'm going to take this material and save it. I've got a fresh filter in here. Here's our solution with the solids that have settled out. And now what I'm going to do is refilter it through a brand new filter paper. I'm going to pull this off of here, put it on a fresh flask, and what we'll do is filter it one more time. I think we pretty much got all the solids out of there, but let's put it through one more time just to make sure we got all that silver chloride out of there. While I'm waiting for this to pull through this filter a second time, I'm just going to get a little bit of it on a filter paper. We want to check and see, make sure. Oh yeah, we got precious metals in solution. Got it pulled through the filter now. Looks like it cleared up pretty good here for us. So now what we're going to do is take a closer look and see exactly what it is that we have in solution. To see what we got in solution, I'm going to get a little bit of our solution out of this flask and put it in the spot plate here in a couple cavities. We've got some ferrous sulfate here, crystals, and what we're going to do is we're going to test our solution by adding just a few crystals to one of these cavities with some of our solution in it. If there's gold in there, that will happen. We get a brown cloud forming around the pieces of ferrous sulfate. Here I've got some DMG, and what I'm going to do is get a few drops of it, add it to this cavity right here. Let's see what happens. There's palladium in here. We should see a precipitate form. This should show you, especially with material like this, how different each refining really is. There's no set procedure. It's all based on what you've got in solution as to how you proceed. Based on these tests, looks like I've got gold in solution. I put DMG in here. Looks like I've got some palladium in solution, and there's probably going to be some platinum as well. So I'm kind of stumped here. I've got a small beaker here. I'm going to reach in and get some of our solution in this small beaker, and it's always best to do a little test amount before we commit and go all in. All right, I've got some sodium metabisulfite. Get a little bit of it and add it to our solution here, and we're going to see exactly what happens. That happens. Now we can see why it's important to do a small test batch before we go all in on the main solution. This is the spill that I just wiped up. Put a little stannous on here to see what kind of reaction we get. Oh yeah, that's a reaction for palladium and platinum in solution right there. If you look down in here, you can see there's some solids down on the bottom. I think that's gold. It's a pretty decent amount too. I didn't realize there's going to be so much gold in my filters. Okay, I think I got the gold to come out of solution. Dip a little, get a little bit on that filter paper there, and let's see what we got now. That looks like a positive test for platinum group metals. Not very much, but all right, I think what we're going to do then is transfer our main solution into a big beaker, try to precipitate out the gold. I hope people can see why it's nearly impossible to give instruction on how to do this. I'm doing this off the cuff, making it up as I go. As I said earlier, there's no way to figure out a set way to do this stuff. It's all going to be dependent on what metals you have in solution. Will dictate how you proceed. Okay, here goes nothing. Got platinum group metals and gold in here. SMB will bring down platinum group metals in small quantities if they are present. So here we go. First spoon of sodium metabisulfite going in. Bang. Here goes another spoon. We got gold coming out of solution in there, man. Wonder where all that came from. Mostly silver refining filters. I don't see a whole lot of gold in there. Dip a piece of filter paper in here and see if we could detect anything on this with some stannous. Very light stain there. Not black like it used to be, so we must have dropped the gold out of this solution. I've allowed this to settle for about 30 minutes. And based on this test right here, there's just a little bit of platinum group metals in this solution. Not enough to try to do a refining. So what we're going to do, I do see a respectable amount of gold down in here. Here's a temporary waste container. We're going to pour this waste solution off and see how much gold we got down here on the bottom of this beaker. It's like a pretty decent amount. Alright, here's our gold, man. It's not a whole lot, but I mean, it's probably going to be a few grams. I'm going to add a little bit of hydrochloric acid and rinse the gold off a little bit here. I think what we're going to do is collect the gold in a filter here. Just going to filter it out of this waste solution carefully. Here you can see we've got a fairly decent amount. Back up in our beaker. Try to get this down into the filter. This is our test amount of gold. I'm going to add that in as well. There's a decent amount in there.
Here's a look at the gold while we've got it in the filter. And what I'm going to do is add a little bit of hydrochloric acid to rinse it out while it's still in the filter.
Alrighty, here's the look at the gold down in the filter. And I think what we're going to do is put it up here on the stir plate. If I can get this camera adjusted right. Put the whole filter right on in. Now what we'll do is add a little bit of hydrochloric acid. I'm going to add a little bit of sulfuric acid. Precipitate out any lead. Now we're going to add a little bit of nitric acid. It's about 1.5 milliliters, maybe just a touch more. And that should do it for us. Now we're going to turn on the stir bar, cover this thing up, add a little bit of heat, and we'll let this redissolve a second time. Everything went in the solution in about 5 or 10 minutes there. Let's put it down off the heat. Let this cool down. I'm adding a couple of ice cubes to cool the solution down. Everything's cooled off now. We're going to go ahead and filter the gold solution. After I got done pouring the gold solution, I looked down in my beaker. Looks like I've got metallic gold in the bottom of this little beaker. I don't know where that came from. Well, I'm going to try to dissolve the rest of this, I guess. A little hydrochloric acid, a little bit of nitric acid. Good Lord. Maybe add a pinch of sulfuric just in case. Every bit of it's already dissolved, less than 1 minute. Turn the heat off. And I'll put an ice cube down in here. Get it to cool off. Pour it right through the filter with the rest of the gold. Unbelievable. Anything that can go wrong will go wrong. Solution is cloudy. So what we'll do is put on a new flask, transfer our funnel with the filter to the new flask, and then we're going to pour this solution back through the same filter paper so we get it to clear up a little bit. Well, that second pass through the filter helped out, and there's lots of trash that we filtered out. I forgot to turn on the sound there. And now what we'll do is take our sodium metabisulfite and precipitate out the pure gold a second time. Here we go. That was fast. I allowed this material to settle overnight, and as you can see, there's still some suspended solids in the liquid, probably platinum group metals. The material that we started with on this refining was filters. That's going to have a whole bunch of junk in it. Gold, platinum group metals, silver, lead, tin, everything is going to be in there. So the starting material is going to dictate how well the refining goes. And here's our finished metal. This is probably going to have some platinum group metals that are following the gold through this process. Notice how it doesn't settle very quickly. And so I'm not going to chase after this and try to get it ultra high purity. I've done that in the past, and it's just exercise in futility. So what we're going to do is going to rinse this out a couple of times with some hydrochloric acid. This is about the fourth rinse with hydrochloric acid. And when you see it do this, when it doesn't settle very quickly, it's starting to settle out okay now, but there's still some suspension in that liquid. That's an indication that we still have contamination. The urge is to try to go after this, refine it another time, reprecipitate, maybe with copperas, and try to get it to clear up and clean up here. But I'm going to get the gold down into this melt dish. I'm going to take it over on the melt table, and we're going to melt it up into a little button. First, let me get a little bit of this water out of here. All right, here we go. Let's melt this up into a button now. All right, that looks like a nice little button of gold, pure gold. Very nice. Let's get some borax on it. I'm gonna want to get it out of there before it freezes. There's our little button of pure gold. All right, here's our little button of pure gold. It's got a little bit of flux sticking to it. I'm going to put it down into our container here. Add a little bit of distilled water. And then we're going to add just a little bit of sulfuric acid to dissolve that little bit of flux off of there. That took about 10 minutes. It got all that flux off of there. Let's rinse this thing off now. Here's our pure gold button. Here's a look at the pure gold button. I'm guessing 98 to 99% purity on this. You can see it's got a little frost on the surface there. Main contaminant will probably be palladium. And what I would normally do is just throw this in with my next batch of carat scrap and re-refine it, and that would make it nice and clean. Let's see what the weight is on this. Oh, 6.3 grams. Not bad. I was expecting a lot less than that. 6.3 grams of 98 to 99% pure gold. This was a difficult refining, but we got pure gold, 6.3 grams, about 98 to 99% pure. Main contaminant will be palladium. And I just got to say thank you again to Paul Ashman. I think I pronounced his name earlier incorrectly. I said Oshman, but I think it's Ashman. Paul Ashman, thank you very much for this contribution. It worked out nicely and came in handy during this video. So like I said, what I normally would do is throw this in with my next refining, but I think what we'll do is we'll put it on my eBay store and offer it up for sale. 6.3 grams of 98 to 99% pure gold. Okay, thank you very much. This will conclude the video.